All right, you guys, let's see if we can finish these notes that we were interrupted by Mr. Brown for. What we are looking to do is go over these 4 learning objectives. So the first 3, pretty review: expressing a fraction as a percent, expressing a decimal as a percent, expressing a percent as a decimal. Then the second part might be a little bit more tricky, which is where we get into, so maybe I'll make that one yellow. Okay, not green anymore. Solving applied problems, determining percent increase or decrease. That's a tricky one. And 6, investigating some of the ways percents can be abused, which is an interesting thing to think about. So I think we went through some of this during class, but if I start talking too fast, just remember, you can always just write down the steps that the book gives you. So for this first one, the book says when you want to express a fraction as a percent, you, number 1, divide the numerator by the denominator, multiply that answer by 100. It says quotient, I said answer. Same thing in this particular instance. Okay, and I would just use the calculator. You can move the decimal if you like. Sometimes that's quicker in your head, but if you are not thinking really quickly, just use your calculator. I would definitely say if you're taking an SAT, use the calculator so you don't make a silly mistake. And then add a percent sign. I think it's funny that they made that one of the steps, but the example that they do is 5/8. So they say you take 5, you divide it by 8. You could just put it in the calculator. Your answer should be 0.625. Then you just multiply this by 100 and you get 62.5. If you just feel like I'm reading this to you, skip forward. So your answer after you add that percent sign, I don't know why that cracks me up, is 62.5%. What I always like to remember, you guys, is that 100% is equal to 1 whole, right? So any decimal, like we had the 0.625, any decimal that's less than 1 whole is going to be less than 100%. So we get that 62.5%, right? If you had a decimal that was larger than 1, like 2.56, then our percent is going to be greater than 100%. This is going to be 256%. So what I've been doing over and over again, those are the 2 steps that you need, which is actually part of the first part, which is expressing a fraction as a percent, is just multiplying that decimal by 100. And so that's what I was doing. And then of course, this book wants you to attach the percent sign. The example that this one uses is 0.47, right? You multiply it by 100, you get 47%. Since I knew it was going to be less than 100% because 0.47 is, actually let's write it this way, 0.47 is less than 1 whole. So I knew that whatever percent I got was going to be less than 100%. Okay. What I would like you guys to do is try this checkpoint on your own. You can either watch this video to the end or just pause this video. Third step, expressing a percent as a decimal number. Move the decimal point 2 places to the left. Remove the percent sign. So if I spoke too fast, pause, write this down in your notes, these 2 steps, while we go through the example. So it's kind of the opposite, right? Moving decimal 2 points to the right takes it from a decimal to a percent. Moving the spot 2 points to the left takes it from a percent to a decimal. So let's look at this first example. We have 19%. I know it's going to be less than 100%, so it's going to be less than 1 whole. If you think about exactly what it's doing here, but I'll just do it over on the side. Any number always starts off with the decimal on the right-hand side of that number. So I'm just changing that percent to be that decimal. Then to make it smaller, you move it to the left. So 19% is actually the same as, sometimes I think about it as cents 19 cents, okay? Since it's actually pretty cool if you think about it in Spanish, percent is por ciento, is out of 100, right? So cents meaning 100, we have 100 cents in a dollar. I like to think of sometimes just as percents as cents, okay? You can also use just the calculator. So if we have 180%, which doesn't actually mean that much in your head when you first say it, you're saying 180 cents would be $1.80, so 1.8. But it is easy enough to use your calculator. We're just dividing. You'd put 180 divided by 100, and you get 1.8. So 180% is the same as 1.8. Again, that kind of makes sense because it makes sense, which is different. See that funny joke I made? Sense. And I said it makes sense. Oh God, I'm gonna get this one wrong. It makes sense. I think this is the one I meant. There's actually another sense, which is, oops. You guys don't make fun of my spelling. Maybe I'm thinking of sense then. But anyway, this makes sense because 180% is above 100%. So we would expect that number to be greater than 1 whole. Okay? So please try these checkpoints. Move the decimal 2 points to the left, or simply in your calculator, divide the numbers by 100. All right, moving on. What is the book trying to tell us here? Can I expect to have a lot of zeros when expressing a small percent? Yeah, and we'll get into this in class, but when we're looking at things, I feel like, especially right now, when we're looking at, we're talking about percents a lot with COVID, and I think people aren't understanding the really small percents there. So let's go over that in class. What's next? Sales tax and discounts, okay? So I always think of discounts when I go to DSW. You guys ever shop at DSW and they have those cards above all of the shoe displays because they're so much on sale? They want you to be able to figure out how much they are on sale. So what does it want us to talk about? It's just kind of getting right into our sales tax here. So suppose that the local sales tax rate is 7.5%. Now remember, if we want to use our calculator, the first thing I'm going to think of is we do not enter percents into calculator. We only enter in decimals. To change 7.5 into a decimal, I divide by 100 or move the decimal point twice. So it's this is actually 0.075. If you want to see what that looks like in the calculator, you put in that 7.5 divided by 100, and you get 0.075. Okay? Be careful, because if you just put 0.75, which I think it's really easy for your brain to do, you are going to get an answer that is way, way, way too big, okay? So suppose a local tax rate is 7.5%, you purchase a bicycle for $894. How much tax do you have to pay? So you have to, and this is cool, look in the book. Here's some of those things you should be taking notes on. Take that tax rate and multiply it by the item's cost. What I like to do is remember what our English words mean for math. If we want to know what 7.5% tax, we want to know what 7.5% of 894, the word of is equal to multiplying. Okay, so we want to know 7.5% of $894. We multiply. So let's go back to the calculator. 67.05. Okay, so we are paying $67.05 in tax. Okay. But the second question, what is the bicycle's total cost? Well, then we need to add that 6705 back onto 894. So 894 plus, okay, so whatever it is, it's gonna have 5 cents. 4, 7, 8, 9, 10, 11, carrier 1, 16. Okay. The total cost for the bike is going to be $961.05. Okay. Now, will you please try checkpoint 4 by remembering what we just did? So you might need to go back and watch it again. But write that down so we can check it when we are together again. All right. Discount amount, so percents and sales price. So this time it sound like taxes you add on top of the price, discounts we subtract from the price. So a computer with an original price of $1,460, sorry guys, is on sale for 15% off. So the first thing I want to know is so you can actually write the whole sentence in words in math. What question mark is equals, what is 15%, 0.15 of multiply 1,460. Now, don't forget in math, our question marks are always represented by variables, and we usually use X. Okay, so here's my little math sentence. So X is equal to 0.15 times 1,460, which if you guys want, you can just put that into the calculator, or fun trick, 15% is the same as 10% plus 5%. I know 10% of 1,460 is going to be 146. And I know 5% is going to be half of that. Half of 14 is 7, half of 6 is 3. So this is just some mental math. If I add those two things together, let's double check. Hopefully this isn't wrong because I do not want to do this video again. So you'll just have to tell me I'm wrong and laugh at me. But 15%, so 0.15 times 1460, 219, bam, my mental math is correct. So either way, it's probably just simpler to type it in, but just so you know, you can do this if you are at the store and need to do this in your head. So X is $219, which X is my discount, is $219, is the discount, right? So what is the computer sales price? Well, if it's the discount, then I subtract. So 1460 minus 219. $1,241. So the discounted price, the new price is $1,241 after we subtract the $219. Now that we've done this, will you guys please pause and try, and I'm not saying try these checkpoints because I'm going to be grading them or you're going to get points for them. You need to try the checkpoints because that is how your brain learns. Just watching me do it, even if you are understanding it and taking notes, is not the same as doing it on your own. When you do it on your own, your brain learns, okay? To make this video shorter, we'll skip this, but read through it and see if you have a question about that in class. Try checkpoint 6, finding percent decrease. So example 7, and let's go down to the next page. So this is something you're going to write down so that you have it handy when you're doing your math. The percent decrease, geez, you guys. The percent decrease is the amount of decrease divided by the original amount. So now I have to go back up and see that question. So the amount of decrease is $60.07. Oh, the sales price is $60.75. The jacket is normally $135. Okay, so this is important. The jacket is normally $135. In order to find that amount of decrease, they have to take the original amount minus the sales price to figure out how many dollars off you are getting, how much you are saving. The amount of decrease is the amount you are saving, divided by the original amount, which is 135. Okay, so they had to put that extra step in there, 135 minus $60.75 to show you how much you're saving. When you do the division, you get an answer of 0.55, which is 55%. So the percent decrease is 55%. Please take a moment if you haven't yet, because I was speaking too fast, and write down that formula so you have it really quickly in front of you, in case you are taking a test, in case you are taking a quiz, in case you are just doing your homework. It's going to be much easier than going back and trying to find it in the book, especially because most of us are going to be having online books. Okay, now doing the same thing, try checkpoint 7. Okay, here's the sale price. Don't forget this little step. Here's how much it sells for. You have to figure out how much you're saving to be the numerator. All right, so in these next examples, we're going to talk about, and here's that last part. I guess this should be the last part of our notes. We look at a few of the ways percents can be used incorrectly. I feel like this especially happens when people are trying to skew data so that it says what they want you to think it says. I just said a lot of words that may not have been in the correct order. So first of all, we're talking about percents of percents, okay? John Tesh, while he was still anchoring Entertainment Tonight, I don't watch that, so I don't know who this is, reported that the PBS series, The Civil War, had an audience of 13% versus the usual 4% PBS audience, an increase of more than 300%. Did he report this correctly? So here we're gonna find the percent increase, right? And this is gonna be the same as the percent decrease, except we're taking the amount of increase and we are dividing it by the original amount. You might wanna write this down also. In order to find the amount of increase, they had to take the original amount, they subtracted, they had to take the new amount and then subtracted the original amount. So there was a 9% difference in between those. So it increased by 9%, divided by the original, which was 4%. So the increase, when you do 9 divided by 4, you get 2.25. You turn that into a percent, you get 225%. The percent increase for PBS was 225%. This is not more than 300%, okay? So what was he doing to get that 300%? I think he was just taking, what was he doing to get that? Was he just taking 13 divided by 4? Is that how he thought it was 300%? Yeah, and then times 100 would give you 325%. So what he was doing was just taking the new amount divided by the old amount, but that's not what you do it. To find the percent increase, you have to find the amount it is actually increased and divide it by the original amount, okay? Knowing that, please try checkpoint 8. on your own. And if you have questions about it, I'll give you the correct answers and we'll talk about it in class. Okay. All right, another example of an abuse of a percent. A politician states, if you elect me to office, I promise to cut your taxes for each of my first 3 years by 10% each year. So he wants to cut your taxes by 10% each year for a total reduction of 30%. Okay, I know where this is going. To make things simple, let's assume a taxpayer pays $100 in taxes in the year previous to the politician's election. A 10% reduction during 1 year is going to be $10. Okay, we can all agree that that makes sense. If it's 10% less, you're gonna pay $10 less. So here's the thing, you're only paying $90 in taxes. So instead of $100, you're only paying $90. So what happens next? The second year, if they get a 10% deduction, the second year, since they only paid $90, the deduction's only gonna be $9, right? So because they're paying less, their deduction is less, or reduction, they're calling it, is less. So the original reduction is $10, but now it's only $9 because you're actually paying less. Then, the next year, since it's $9 more of a reduction, you're only paying $81 in taxes. And 10% of $81 is only $8.10. So if you add up 10 and 19 and 8, or what it's doing, it's going to actually use our decrease. If you take 100 minus 72.90, because that's what you're going to be paying the next year. So you figure out the savings, you're saving $27.10, which is what you get when you add those three numbers up and divide it by the original amount. You're only saving 27.1% as opposed to what he was saying, 30%. Okay, so the taxes decline by 27.1%, not by 30%. Okay, and that's because since you are saving every year, each year the reduction is actually less. Okay, this is what we talk about. We'll get into when we talk about interest rates and things like that, and there'll be oh my God, my train of thought is, this is how tired I am, you guys. I'll talk about it later since my train of thought just left the station. So please go back through what I did, try checkpoint 9. And I would do the same thing if I can get you started on checkpoint 9. Suppose you paid $1,200 in taxes during year 1 and taxes decreased by 20%. During year 2, taxes increased by 20%. Okay, so what did you pay for year 2? I would just set it up in the table, right? Taxes paid the year before. The first part would be $1,200. And then the second part of the table was the reduction, which is 20%. Okay, and set up the table like that. And we can go over this during class. All right, that is it. I want you to try it on your own, but we'll go over it. And the homework problems start where it says practice exercises.